Hello, this video is all about algorithms. We'll discuss ways you can critically evaluate an algorithm without having to understand all of the coding or math behind them. You can think of algorithms as a set of instructions. In some cases, a set of instructions for a human can be simple, such as making a peanut butter jelly sandwich or a salad. However, when we discuss algorithms, we are usually referring to those done by a computer, like commands that allow you to quickly sort a list of names alphabetically, or make a graph in Excel, or even determine the fastest route from Atlanta to Orlando using real-time traffic conditions. Algorithms can vary in their complexity, but you can understand them as a set of instructions or equation applied to data with a goal of completing a task. For example, Netflix uses a recommendation algorithm with a goal of recommending you titles that you want to watch so you continue streaming their content. Netflix uses how you've rated other content, what you've watched in the past, what you just finished watching, what time of day you're watching, and specific genres. All of this data then goes through an algorithm, which produces a title to recommend you. Algorithms are measured by their efficiency and accuracy on how well they complete a task. So how would we evaluate Netflix recommendation algorithm? If their goal is to recommend you titles that you'll want to watch so you continue streaming Netflix. After you've streamed your favorite TV show on the app, it will promptly suggest another title to watch next. This happens quite quickly, which is an example of its efficiency. As for its accuracy, Netflix has reported that 80% of what users choose to watch next is based on their recommendations, meaning that users usually select one of the titles the algorithm recommends. We could interpret this as the algorithm being both efficient and accurate. However, individual users, such as yourself, may not agree. Oftentimes, we do not know the algorithm that is being used. A company might not want to share that information with us, or maybe it's just too complex to understand unless you're an expert in that field. Or the algorithm could have been created through machine learning, which we'll discuss a little later in the video. However, you do not need to understand all the inner workings of an algorithm or statistical analysis to be critical of how they are used. Due to the complexity of algorithms, they are often referred to as black boxes to represent how it's difficult for the average person to know what's going on inside the box. But most of the time, we don't need to know what's happening inside the box, but instead what's going in and what's coming out. Data goes into the box, or the algorithm, and a result comes out. Even if you don't understand the algorithm or statistical analysis in the black box, you can still be critical of what goes in the box, the data. Let's say a company wants to make the promotion process for their employees fairer by removing the promotion committee that they worry might be biased. So they take all the data they have on folks who've been promoted in the past and who've done well at the company to create an algorithm to select who should be qualified for the next promotions. So that data goes into the black box, and out comes a list of who to promote. Why would this algorithm be problematic? Well, if the company has had issues with being unfair, discriminatory, or biased in the past, then the data going in is already biased, meaning the algorithm is only going to reproduce that bias. You can evaluate an algorithm by looking at the data. Is it good data, or is it bad data? If it's bad data going into a black box, it's going to come out as bad results. So if you can be critical of the data, then you can also be critical of the results and the algorithm. Machine learning is a subfield of the study of artificial intelligence. Instead of a human writing a complex algorithm to complete a task such as identifying an object in a picture, a person can write an algorithm to initiate machine learning, which is where a computer can develop a new algorithm to complete a task based on training data. If you want an algorithm that can identify when a flower is in a photo, you'll need to train it by exposing the algorithm to numerous photos with flowers in them and numerous photos without flowers. For instance, all of these photos could be used as training data. Eventually, the algorithm that results from the machine learning should be able to identify when a flower is present in an image when you present it with new images that are not in the training data. This process could also work with identifying a dog in an image. Machine learning continues to advance. And now if you're at a park or on campus and you see a flower you like, you can simply pull up an app, take a photo of the flower in question, and an algorithm can pull up exactly what type of flower it is. However, the data used to train the machine is extremely important. If you only used cartoon drawings of flowers, your flower identification app wouldn't do so well with real flowers. Machine learning has been used to build tools such as automated chat boxes. Microsoft created an AI chat box that was trained through interactions on social media. Eventually, Microsoft had to remove the chat box because it started using the racist and sexist language it had learned from the human users. Many job applications now go through an AI program narrowing down the final applicants for employers to interview. Universities are testing algorithms to help them with determining who to admit to their schools. Some are excited about the prospects of AI programs making these choices, while others are fearful of the consequences. Will these complex algorithms work to reduce human bias or exacerbate it? It's important to think about the data that's being used and who benefits from the algorithm and who could be harmed from the algorithm. It is important to remember that biased data creates biased algorithms. Even if you cannot understand the details and complexity of an algorithm itself, you can think about the data that goes into an algorithm, machine learning, or AI.